So, the talk I am going to be giving is on production-ready microservices. How do we build these microservices at scale at Gojek? So I am Rajeev. I work as product engineer at Gojek. So before starting ahead, right? So who among us, like a quick show of hands, who knows about Gojek? I think most of the folks, right? Yeah. So, so as you know, we are competitors for Grab. This is okay. I'll just use this. So, Xin Chào, Vietnam. So this is my first time in Vietnam. So it is a pleasure to actually come here and talk with you guys, share experiences of. Okay, what happened here? Okay, sorry for this. So it's a privilege to come here and actually give a talk in front of you guys. It's an honor. So just a quick introduction of who am I. So I am Rajeev. I am product engineer at Gojek. Have been working with Gojek for last 2.5 years. So has seen from initial days of Gojek to the way it scaled across multiple countries and also at the scale which it is at currently. So I am into distributed systems, security and data. So I build distributed systems at scale. I try to build reliable distributed systems at Gojek. Yeah, so that is my main focus area. So I tweet a lot about distributed systems at my Twitter handle, and I open source some code at Ashati, so you can just go and look there. Okay, so this is about Gojek. So Gojek has around 18 plus products, as you guys know. So we are basically into transport, logistics, and hyperlocal delivery and payments. So we have over 1 million plus drivers. We have around more than 500 microservices. And among them, more than 200 are written in Golang. So that is what I am going to be talking about, how we build services at scale using Go. We have around 15K plus cores, 2 cloud providers, 6 data centers, and around 100 million plus bookings per month, right? So recently, we expanded into other 4 markets, as you guys might know, with Go Viet being in Vietnam. So we expanded to Vietnam, we expanded to Singapore, soon be expanding to Thailand and Philippines. So let's go with the agenda. So what will be the talk about, right? So we'll be talking about what, for me, it means as production-ready microservices and for Gojek. Okay. So why do we need them? Like you might ask, why do I need to care about building something which is production-ready? Why can't I just put something in code and just put it somewhere, right? So how do we build them? So we'll talk about how are we trying to build services, like which are basically in Go. And we'll talk about what is the feature work with respect to the current thing which I'm talking, and we'll conclude it with a conclusion and key takeaways from the talk. So long time ago, so in startup ecosystem, long time ago is not that far ahead, right? Not that far behind. I think it's 2 years back. As with any other startup, Gojek had one big monolith, right? It's one system where everything used to happen. There used to be payments, there used to be transport, there used to be food del, OMS, all of those in one single giant monolith ecosystem, right? And if you think that was working out fine, right? It helped us scale to a certain level. And it helped us first grab some market, right? But there were problems as Gojek grew organizational-wise, right? So as we hired more number of people to work on these products, there were a lot of problems with respect to a single monolithic code base or a service, right? Too many people were stepping on each other. There weren't independent deploys which were happening. There was no proper communication which was happening. So people were breaking each other's stuff always. So that used to happen with the monolith earlier. So our monolith was called as MARSH, right? From the famous South Park character. So we kind of trying to kill it now, right? Because we want to go towards complete microservices. So if you think, right, initially we had monolith and we split them into microservices now. You basically think that there was one problem earlier, right, which was monolith. Now you have 500 plus problems, right? Because now you have 500 plus microservices and you have to handle all of them. Now, there needs to be a certain level of discipline when you actually want to put any service in production, when it particularly comes to microservice architecture. can't just put everything in production because it will be affecting millions of your customers and you don't want to make them, right, go away from your platform. You want them to use your platform. So, as with anything, there was a magic pill, right? If you are unable to scale your monolith, go with microservices, right? So how many of us actually have deployed microservice in production? Any kind of microservice? Around 30 people, right? So we'll go with basics of microservices, like what does a microservice mean? And then we'll go ahead, what is production ready, and then we'll move ahead. Okay. So microservices, right? So who has read this book called as Building Microservices by Sam Newman? I think if you haven't, I definitely recommend reading that. So Sam Newman, according to Sam Newman, microservices are basically small autonomous services that work together, right? So these are services which have their own cycle of deployment, right, development, right, and only interact with other systems through a well-defined concrete interfaces. You have to basically make sure that the contract with your other service is met. So that is how they communicate with other services. So this will help your teams grow independently because now they can actually build, ship, deploy independently without relying on anyone else, and all they have to care about is a contract with the other services which they are relying on. Okay, so now we know about microservices. Now what does production ready means, right? We are talking about production ready microservices, but what does it mean for us? So production ready microservices are defined this way, right? So production ready microservices are stable, which means that you have a stable development pipeline, which means that if I develop something and push it to production, it should not break. It should be stable enough to handle, right? It should be reliable, which means that if I am actually taking a microservice to production, it shouldn't break someone else. It should be reliable for your consumers. It should be scalable, which means that currently if it is handling around 100 RPS, it should be able to scale along with your customer growth, right? How do you do that? It should be performant, which means that it shouldn't basically have your customer wait for a long time to book a ride, for example, in our case. So it should be performant. It should return response within milliseconds, right? Sub-milliseconds. It should be fault tolerant. Now, if we see in a large-scale microservice architecture or distributed system architecture, things will fail all the time. And basically, recovering from these failures and actually gracefully degrading your services is actually very important. And we'll talk about that also, how we'll be doing. And it should be monitored, right? So if you don't know what is happening with your microservice which is in production, if something fails, you don't know, right? You don't know what to do with it. So you need to know whether my cancellations are increasing, whether my bookings are failing, right? So you need to track those events which are happening within the system. And it should be prepared for a catastrophe. Like consider multiple systems fail and your bookings have stopped going out, right? So how do you actually prepare for it? What are the set of things or processes you need to bring within the organization so that we actually recover from this catastrophe? And it should be secure. I think this is highly important, right? Because I have seen companies going down because they just weren't secure enough, right? Their database got exposed. Right? You should be extremely secure when it comes to building a microservice and deploying it to production. So at the end of the day, you might think, right, all those aspects, all those technical jargons which I just threw, at the end of the day is just building trust, right? You should trust your microservices which you put in production, right? Otherwise, there is no point. They will fail definitely. You should be trusting your microservices. That is the main motive behind this. And bringing back to the same time, the thing is, the goal is to make sure that we are available to serve our users, always, right? We shouldn't go down even for a minute, I would say. But that's an ideal world, right? Things go down. But you should at least try to make sure that things go down as much as possible. So now we talked about what are the problems, right? And we understand that we want to build production-ready microservices. Now, how do we do it? So at Gojek also, we had similar problem, wherein you had this explosion of microservices. Too many people building microservices, putting it to production, things breaking, because there were very minute things which people weren't thinking about, right? They weren't disciplined enough to actually think that, okay, I need to take care of these 10 things. So to explicitly tell it out, that, okay, you need to think about these 10 things because it would affect our customers in so and so way is something which is resulted into this production ready microservices checklist. So we call it as a production readiness checklist. Right? It's a checklist of items which you need to take care of when you actually want any microservice to go to production. Or even if there is any microservice in production, if you basically tell that it is production ready, only if it is basically going through all the points which I will mention in next slides. So you might ask, why do we need something like a checklist, right? So it's too process-oriented, right? Like it's like developers don't like process. Like, no, we don't want to have processes in place, right? So why do we need it? So Gojek was going through an organizational sprawl, right? So we were hiring more developers, expanding to more markets, right? Which means that there were more teams forming, right? Which means that there were more services which were getting shipped to production for serving our users' needs. Now, when those things happen, you want to bring in this discipline which basically which binds them together, telling that, okay, make sure that you meet this quality before putting anything to production. I can't just take anything and put it in production. The other was technical sprawl, right? I think one of the talk also mentioned that it's very bad for ops people, right? If everyone starts to use their own language, right? You have to standardize on the set of technologies, tools you want to use within your organization, right? And also basically have these checklists, production readiness checklists associated with all of those technologies. The increased developer velocity, right? Like people used to deploy like more than 50 times a day, right? All the code bases across multiple microservices. When there's such high velocity of deployments, you want to make sure that your deployment pipeline, your production environment is stable enough. And it is also fault tolerant. So again, coming back to the main thing, you have to build trust and confidence in your code, which you are putting in production. Also build that confidence among your users, so that they believe that whenever they are trying to use your service, it is always available. So that is the most important thing. So let's begin. So we'll be talking about these production readiness checklists at various levels of abstraction. We'll start with the code, right? Because everything you do in production starts with a code, right? Because the code is the one which actually runs as a process and serves your user. So we'll talk from code to at a higher level architectural layer. So let's begin. So this is the standard thing, right? Like you might have heard of code reviews. It's basically WTFs per minute, right? Or whatever that is. So the gist being that the code quality which goes to production should be top-notch, right? It should basically take care of certain aspects so that it doesn't break in weird ways. And also for the people who actually change that code, it should be easier to change. So we'll talk about those aspects. So most of these will be familiar with you guys because let's go. So let's start with linting and formatting. Like how many of us actually like religiously do linting formatting of all the code we put into production, right? So most of like I think around 30% of the people. Thing is that Golang has provided you these tool chain to actually do this. So why do you think this is important? So we'll talk about why do we think that linting and formatting is important. So linting and formatting is basically statically analyzing code for any linting or formatting errors. There is a standard format in which you have to build your Golang application or your source code should look like. So it will basically, linter will try to help write idiomatic Go code, right? If you think, right? So it will basically tell with respect to whether there is certain documentation which is missing for a publicly exposed endpoint, right? As simple as that. It helps improve readability of your code. Like if someone reads your code tomorrow and is willing to change that code, it would be very simple for them to change because your code has clear interfaces with well-defined documentation with it. Makes code easier to change, as I mentioned. These are the standard set of tools which is part of your tool chain, right? So making this part of your day-to-day development and deployment process is a must, right? There shouldn't be any code which goes to production without these checks in place. So that is something which needs to be taken care of. So the other thing is we'll talk about code smells, right? You might have heard of these code smells from like object-oriented world, right? People talk about cyclomatic complexity, dead code, right? Cyclomatic complexity is basically how many branches do you have within code? What is the degree of branching? Dead code, of course, we know duplicated code and error checks. So we all agree that we shouldn't be doing some of these, right? These are code smells when you have something like this. So basically, going back to the same aspect, that this will help actually keep your code quality in check. So that whoever changes will be having a sanity on the code base, right? Basically helps maintain sanity. Like whoever reading wouldn't go crazy when they read your code. And who has used Go meta linter here? Anyone? Okay, one person. So Go meta linter is basically a linter of linters. It basically takes a bunch of linters with respect to error checks, dead code, multiple things. And basically it runs all of them concurrently. And I think this has helped us a lot because it would help us find some of these problems in the code base. Okay, so this is how it looks. So it finds for some of the things like, okay, ineffectual assignment to error, right? And something like, okay, declaration of error shadows declaration at our outer level. So these are very concrete things which you can actually go back and fix in your code. Okay, so the last thing in code quality is secure coding, right? So we all believe that security is an important aspect, and the code you write should also be secure, right? So, but how do we check it? How do we know that our code is secure, right? There are tools for that too. So, secure coding is basically inspecting your source code for finding security problems, right? Statically analyzing it. So, some of the statically analyzing tools help you find SQL injection vulnerabilities. It will help you find hard-coded credentials. And if you think hard-coded credentials is one of the top things, right, because of which sites get compromised, because you just checked in a credential into your GitHub account, right, publicly available, right? Whole companies went down because of that. As simple as that, just checking a hard-coded credential, right? So it's very important that you actually statically analyze your code before pushing anything. It is even bad. You might tell that, okay, I have a private GitLab repo or a GitHub repo, right? But it is still bad, because if somebody is able to enter your ecosystem, they still shouldn't be able to find any keys available anywhere. I think you might heard of Target breach. I think that's a classic example, wherein they actually were able to enter the internal network and were actually able to get the credentials in one of the GitLab accounts, which they had maintained privately. So basically telling that you should not have hard-coded credentials anywhere. And SQL injection is something we already agree with. So basically it will help us write secure code. And GoSec is the one which basically finds all of these vulnerabilities. Like it looks for hard-coded credentials. So basically it has multiple strategies. Like it basically applies all of these algorithms and tries to find whether any of these are true with your code base. If it is, then please fix it and then push it. So wrapping it up with respect to code quality. So this is how it looks. So if you see there are errors unhandled. So this also talks about unhandled errors, right? Because it could be a problem in certain cases. So closing comments on code quality. So make it part of your development process, right? Have a makefile which basically, before pushing, make sure that it runs linting formatting. I would rather say have a pre-hook for your commit, right? So that when you actually commit, make sure that you run linting formatting and then push, right? Add it in. So there's a sample project called as Hemdal, which you had open sourced. So that has these practices implemented. So make it part of your build pipeline, right? Your build pipeline should have a code quality step, which basically checks for all of these. And then changes to the code base becomes easier, because now you are working with a code which is same. And among the things which we mentioned with respect to productionality, this will help you maintain stability and reliability of your microservice, right? Because the code doesn't just go into production and break. You have certain checks in place to make sure that that wouldn't happen. Okay, so let's go to the next one. So testing, right? Okay, so how many of you believe this is true, right? So I wrote a bunch of code, right? I am like a 10x developer, right? There is a concept of 10x developer. I'm a 10x developer. I don't need tests. I am like so awesome that I'll just push code, right? That is also a thing which is out there in the market. But we believe that testing is extremely important. How much ever awesome developer you are, like, or you think you are, right? So let's start with various ways we test our application, because testing is extremely important to find various kinds of bugs before you actually put something in production. So let's start with unit testing. So a quick show of hands, how many of us do religious unit testing? And I'm not talking about test-driven development because that is completely other game, but just unit testing. I think around 50% of the room, right? So we all agree that testing is extremely important, right? Because it will help find various things within your code. So we'll talk about that. So unit tests basically help test you a particular unit, right? It could be a function, it could be a class, right? In our case, in Golang, it could be as simple as maybe you're testing a function which is attached to a struct, like a method, right? These are run very often, right? So these are the ones which will continuously give you quick feedback when you're developing. Like consider, I have written a functionality, I have written unit test for it. If I'm changing anything to the code, I'll quickly be running these continuously because I'll be checking whether this change which I made in the code has broken my test, because that is the contract which I wanted to go with. So these are very large in number, right? Unit tests are the tests which will be the highest in number, right? Like they will be in thousands, right? If you have like a decent sized microservice. So with respect to testing, there are other kinds of practices called as TDD. Like how many of us actually do TDD for our code bases? I think one person. Okay, so this is something which is very rare, right? There are other aspects of like advantages with respect to that which we'll not talk, which is out of scope for this. So you can come and meet me if you want to know more about it. So and tools with respect to testing is like Golang has a very good like packaged testing tool which you can use. Apart from that, if you want to do assertions, so we use something called as testify assert. I think most of us would be using that for assertions. So do you guys think unit tests are sufficient? Like I have written unit tests for my code base, now I'm fine, I'll go to production. Do you think it is fine? How many of us think it's not fine? Right? So I think people only on this side are raising. So I think around 50% believe that, okay, these are not sufficient, right? Why? So let's see this. Right? So let's see this tweet. So running integration tests, right? Ship still afloat. After 4 watertight containers flooded, pass. So our unit test has passed. Band still plays after collision with iceberg, pass. Right? Bands are still playing, but your ship is sinking. So what do you need here? You need integration testing, right? So unit testing among themselves wouldn't find whether your integrations of multiple components are working fine or not. So you need one more higher level of abstraction in testing, which is at a higher level I want to test whether everything works fine. So integration tests help in testing multiple components working together, as we saw with the ship analogy. So it will basically help you know what are the end-to-end flows, right? Whether if I make actually a request to a particular endpoint, would I be able to get a certain response back? As simple as that. These will be lesser in number than the unit tests because these will be covering higher level customer-driven use cases, right? So these will be lesser than your unit tests because unit tests are much more at a granular level. And this will basically help finding regressions in your code base, right? Like if you have made any change and if it has broken some user flow, this will help you actually know it because your tests will start to fail. So there is a thing called as BDD, behavior development. So we use Godog extensively for this. So the test, so this is the link for that. And the test looks something like this, right? Like under a customer legacy login, right? Something like that. So this is something which could be easily read by someone who is in business, right? Like a PM or someone, like he'll be able to read like, okay, in order to access application resources, as a customer, I need to log in with my credentials. And basically I have to do blah, blah, blah. So these are the things I have to get. When I generate a certain request, I should get a certain response back. So this is a standard thing, a feature or a scenario which you implement. And basically these are the steps which will map into code, right? And then you can write code for it. And you basically run these feature tests. Okay. So from integration testing, a quick show of hands, who actually knows about what are contract testing means? What is a contract test? I think 2 or 3 people. So this is also very important when it comes to microservices and you're building some kind of API layer, right, for actually serving some responses. So what it helps is, it will help test API contract between a consumer and a producer, right, a provider. So a client and an API is basically client could be another microservice, right, which is talking to another microservice. So basically to make sure that the contract between these two microservices are held always, you need to write a contract test telling that, okay, this contract we have agreed upon and we should agree upon when there are further changes done to the code bases. Otherwise, we'll break in production in unknown ways. We don't want to do that. So this will help protect against any change in contracts of the provider, right? If tomorrow, consider for the same API version, the provider actually changes the response format, I will break badly, right? So what is the guarantee before I going to production or the provider going to production that our contract is met? So that is, using contract testing, we'll be able to do it. So these are actually very low frequency runs, right? We run once a day, right? Once at night, you basically schedule these and see whether the contract between multiple microservices are still met and working fine. So there's a concept, this is a very old concept, I think in 2004-ish, in Martin Fowler blog again. So there is a concept of something called as consumer-driven contract tests, right? So a standard contract test looks something like this. So let me go here ahead. So this is from Martin Fowler blog. So if you see, there is something called as test double. Now test double is nothing but anything which basically mimics your provider. It mimics by returning a stubbed response. Now, what you do with respect to actual integration contract test is you actually make a request to your provider and you make a request to your test double and compare the results. Like see whether the one which is running in production, my provider, and my test double are in sync. If they are not, then most probably provider has changed the contract, which I know about. So that is how I break the test. But you might see there is a problem with this approach, right? Do you think this, like any problems, glaring problems with this approach? Wherein I actually make a request to a provider and then check it against it. So one thing being that what if the API on the provider side is a mutable operation, right? Which basically changes state in the server, and you don't want to do it in production, right? You just, for running your contract tests, you just don't want to, or even on staging, right? You don't want to create any kind of data which is like not valuable. So there is a concept of consumer-driven contract tests because of this problem, wherein the consumer and the provider, we know about consumer and provider. So the consumer actually writes these contract tests and actually gives it to the provider for provider to run it as part of their CI pipeline. So that when the provider is making those changes to their APIs, they will run our contract tests. And if the provider changes any contract, it will break the provider's CI build, which means that they can't actually deploy to production, right? And there is a way to do this in Go too. So actually Pact has these libraries in a bunch of other languages. But in Go, there is something called as Pact Go, which will actually help you write consumer-driven contract tests. So everyone might have seen this in the Martin Fowler blog, right? There is a test pyramid. So we talked about what are the tests which are higher in number, what are the tests which are less in number. So if you see, unit tests form the base of this pyramid. It's called as test pyramid because they are more in number. And then as and when you go up, your integration tests, your contract tests come in, right? So this is how the test pyramid is divided. So apart from just these kind of tests, we want to do load and performance tests, right? Because now you are putting something in production which will be actually hit by whatever the number of users you have, right? Those many number of users at scale will be using your application, and you don't want your application to just die because of the number of users who is using your application. So you want to make sure that your application can handle that load. So that is where the load and performance testing comes into picture. Excuse me. So you test behavior of your app under various loads. So there are multiple kinds of loads you can actually generate and test how your application performs. So this will help you find performance bottlenecks. As simple as whether my connection pooling to my database is proper, right? Is there a bottleneck in connection to the database? Is my database provisioned enough? Or my app servers are provisioned enough, right? Do I know what is the response time I want to maintain? What is the SLA I want to give to my service, like my consumers, right? So those are all the things you can decide just by running load and performance. So these load tests run at, like, it's called as soak testing, right? You basically continuously try to hit your microservice with a certain number of requests, keep it over a period of a long time, you'll be able to find whether there are any memory leaks, right? That's like a standard issue with respect to Golang at least. You will see a lot of Go routine leaks for not closing the response body properly when you're making a request, right? So those are like the standard things. So you'll be able to find those. So it will help you with capacity planning. As I was telling you, you'll know what is the RPS I can support using consider a VM of so and so size with this application. What is the thing I can support? How many instances I need to provision so that I can actually prepare for 10x the traffic what I'm handling now, right? So those are the things you can actually think about. And with respect to SLA, so it's not actually an SLA, it's actually an SLO, which you can tell that, okay, I want to be up for 99% of the time, or I want to 99% of my requests, right, should be served within 10 milliseconds. So that is something I always set for my application, right? And you can set that based on your load and performance testing and also your capacity planning you want to handle. And these are the various kinds of tests you can do. Like the step load is stepwise traffic increase, linear load, linearly increase it, spiky load, like sudden burst of traffic, how does your application handle it? A lot of applications we have seen just crash when there is a burst of traffic coming in. Like how do you find those out and how do you fix those? So these are various kinds of tests you can actually set up. So internally at Gojek, we have this framework set up, which basically runs against all of these different kinds of load and make sure that your application passes those. If it doesn't, it can't go to production. As simple as. So one tool, the legacy tool which you used to use was Gatling. So you have to write in Scala for actually performing load tests. Recently, we have started to use something called as Vegeta. So this is written in Go. And this is certain like result which you get out of it, right? Like you can basically see what are the requests, duration, latencies, all the latencies, 99th max, what is the success ratio, what are the status codes you are getting. So with respect to this, you will have a clear idea, like if I get this traffic in production, how will my service work? Once you are clear with these numbers, you will be confident enough that, okay, I can go to production. And even if I get 10x traffic, the traffic I'm getting now, I'll be fine, right? I'll be out of the woods. Okay, so the last one we're going to talk about is chaos testing in terms of testing thing. So this is, chaos testing is about breaking systems, right, to understand their behavior. So you basically go and like randomly shoot down one of your instances, right, and then check how does your application perform, or two instances for that matter. Or if you have HA on your Postgres, you'll just randomly go and kill your master, right? Or you just go and kill your slave, right, for that matter, and see how do your reads perform if you're reading from your slaves. So it is basically a controlled failure injection, which means that in a controlled environment, you inject failures and observe the behavior. Because one thing which we learned about microservices and distributed systems as an industry is that things always fail. And we have to prepare for those failures. That's the only way. And how do you simulate these failures? Is by actually injecting those failures into them. And then understanding how my application behaves. So this will actually help you in determining unknown unknowns. So you don't even know that, okay, there is actually something which could break in this scenario. So if you do these kind of tests, you'll be able to find some of those things. So it's a resiliency testing pattern. So at Gojek, we have started to automate it, but currently it's a manual process wherein you basically like we'll have exercises in place, a game day exercise it is called as. You go and bring down certain servers, see whether you can actually do a failover properly, right? So those are the things which we do, but it could be automated in the future. And I think you might have heard of Netflix Simian Army, right? The chaos testing, conformity testing, the latency monkey, and all of those monkeys, right? Which basically either shoot down your instances, they shoot down the regions, they shoot down zones, or they increase latency within your network bandwidth, right? So all of those basically help you inject these failures and understand how my system behaves. So closing comments on testing. So it should be an integral part of your development process. You should be continuously running them, checking them whether they actually fail. It should be part of your CI/CD pipeline. No code goes to production if any of these tests fail. It helps build confidence, as we talked about, and also it will help us move faster. Because now you'll be confident to do more deployments, because I'm sure that I have this, confidence in actually deploying. And it will help with all of these aspects. It will help you with stability, it will help you with performance and reliability. So the third one is the resilience patterns. So resiliency is basically to recover if there are any problems in your system, right? Like consider some nodes going down, some database going down. How do you recover from those failures? Or your dependency like a downstream service, right? You are dependent on B service, which is called by A, and B goes down. What should you do? How should I be safe myself, right? So those are the things which come under resiliency, and we'll talk about what are some of the resiliency patterns we can implement in Go. So first thing is the timeouts. So timeouts is as simple as saying stop waiting for an answer after some time, right? So you're making a request to some downstream service or a database. If you don't get, or a storage layer, right? If you don't get back some reply within a certain time, you should stop asking it, right? So you should tell that, okay, no, I will fail fast. So who among us knew that default HTTP client has infinite timeout? A quick raise of hands. I think 3 people, okay. So this is extremely important, right? Like if I just go and do a new HTTP client, it will get initialized with the default HTTP client, and I will have an infinite timeout. So basically, if I'm actually using, if it uses a Go routine to actually make a call to a downstream service, that is blocked forever, right? That Go routine will be waiting for an answer from that service forever. And you don't want that because you are utilizing resources of your system. And you want to utilize those resources for serving actual legit customer users, right? You don't want to just block yourself. Having said that, there is a way to set timeout, but it's just that it is not explicit. So it will basically help prevent or recover from failures when dependencies fail or slow down. So there is a service B and a service A, and a service A is calling service B. B has slowed down or it has failed, right? When you actually make a call to B, it wouldn't respond. So rather what you do, you basically stop making calls to it, or you tell that, okay, I will basically cut this connection. I will not make calls, or I will fail fast. It's the concept. So this one is required at your integration points. Now your integration points is when you actually call your storage layer, when you call your other service, anything, right? All those integration points. So this comes into the philosophy of failing fast. If someone is not replying, fail fast and be safe. So we wrote a library around the standard HTTP client itself, which makes thinking about timeouts explicit. And this is a simple thing, which this is open source as Hemdal. So you can go to GojekTech, github.com/GojekTech, and you'll find Hemdal as the thing. So it does maintain the same contract which the standard HTTP client has with respect to GET and all those aspects. So actually it has a do kind of interface also. But also it has this way of telling that you have to explicitly send me a timeout, right? Build a timeout and send me when you are doing this. So the next thing with respect to timeout, with respect to resilience patterns is the retries, right? So you made a request to service B and it failed. Do you think you should retry, right? That's a business case. It depends on business to business. It depends on whether I should actually retry, whether the service will be back up immediately or will it take more time, right? So retries are as simple as when something fails, make a request again so that it might succeed. And this comes to a concept of eventually succeed versus something called as fail fast, right? Fail fast is like completely opposite of eventually succeed, right? So there are different trade-offs with respect to eventually succeed. So eventually succeed could lead to bad customer experience, right? Because now you are waiting or retrying for a certain interval to get response from your upstream or downstream service. It will have a very high latencies for your customers. They will see that, okay, your page is loading slow or whatever, right? So those things are bad. So you have to carefully look whether you want to do in a synchronous request response or it should be asynchronous. So, but retries do help in recovering from temporary network glitches when you're actually calling some other service. Like if there is a temporary network glitch wherein you did not get an answer, you would be able to basically recover from it quickly. So the other thing is idempotency. So idempotency becomes extremely important when you're actually reading. Like if I'm making multiple calls to the same API, and if the state changes in weird ways, right, then it's a problem, right? Like consider, for example, if I am making a request to payment, telling that debit from this customer's balance, $10, right? If I do it twice for the same thing, if I'm retrying, if it debits $20, customer wouldn't be happy. Especially when it comes to money related, right? One will be happy when their money gets deducted twice. So you should explicitly think that whether your API endpoint, which you're trying to retry, is idempotent, which means that it will always make sure that $10 is the one which is debited. And this is an example. So basically, Hemdal supports multiple backoff strategies. So retrying actually comes with a backoff. You can basically tell that I want to retry this request by either constantly back off, like waiting for 2 milliseconds and backing off, or I want to exponentially wait and then do it. So this is available as part of the documentation. You can just go and see there. So the last part in circuit breaker is, in the resilience patterns is the circuit breaker pattern. So how many of us have heard of it? Okay, around 20% people, right? So this is basically telling that we want to circumvent calls when calls to dependencies fail. Like as I talked about example A and B, with respect to timeout, you basically tell that I will basically like cut that connection, right? But the next request, I still might make a request to it, right? But I might fail. But with respect to circuit breaker, if I know that, okay, certain number of requests are failing, then I'll stop making calls to it because I want it to recover. So that is what circuit breakers come into picture. So once you circumvent a call, you should always think about a graceful degradation path, right? You should think that, okay, what if I fall back to a fallback response? What will be my fallback response? And how would it look as a user experience for my customers? So that is extremely important. So this is also a fail fast. Hystrix is a well-known implementation. I think everyone uses Hystrix for doing circuit breaking. So this will actually help recover back both the systems which are slow, which you are making call to, as well as your own system. It will protect both of those systems. And this is a standard state transition diagram. Like initially when everything is well and good, you are in the closed state, right? If something starts to fail, you go in an open state. And if the next request fails in an open state, you will go to half open state. And if a next request fails in half open state, you'll just go to open, which means that when the state transition diagram is in open state, you'll stop making calls to your downstream service. You will tell that, no, the system is failing, let me stop making calls. And then once, after some time, after sleep threshold, you will check back again whether my service has recovered. If it has recovered back, then I will go back to the closed state and start making requests to it. And there are various, so with respect to Hemdal, this is how it looks. So you can set various things like max concurrent requests, error % threshold, sleep window, and what is your fallback response. So if you set this, then it will make sure that when you're actually making a request, it will basically take care of all of this. And this is a classic example of fallback, right? In Gojek's case, I think if you guys might have used the app, if everything is well and good while finding the distance, right? The one on the left will actually find you the Google routed distance, right? It's a road distance. It will find that, okay, this is the path you have to take. But consider, because of some reason, Google is slow or it doesn't work fine, because we rely on Google for these distance APIs. You basically fall back to a fallback response. It looks like a straight line. You tell that, okay, this is just a straight line, it's a fallback. So instead of failing and not accepting bookings from your customers, you rather tell that, I gracefully degrade it. It might be a bad experience for my users for a time period, but eventually my systems will recover and they will be seeing that, rather than stopping making bookings. So closing comments on resilience patterns, right? So it will help protect systems and dependencies from failure. Fail fast is the mantra here. So it is needed at all of your integration points, and you have to think of fallbacks at your integration points. And it helps with some of these aspects. Okay, so how many of us have heard of observability? I think this is the new jargon which is floating around in the market, right? The software industry market. Like everyone says that, no, we are not doing monitoring, we are doing observability, right? Like monitoring is like the non-cool term now. Like if somebody tells monitoring, like no, that's not a cool company anymore, right? So observability, so I think if you guys follow Charity Majors on Twitter, so this is what she tells about observability. So observability, I'll just read it out, is about being able to understand the inner workings of your software and systems by asking questions and observing the answers on the outside, right? So I should be able to ask any question to my system and I should be able to get an answer from it, telling her, okay, yeah, this thing happened. So that is, a broader terms, is what observability means. So most of the people have like broadly categorized into 3 things. They basically talked about monitoring, logging, and distributed tracing. So we'll not go into distributed tracing because that's like a complete talk in itself. and we'll talk about monitoring and logging in this. So monitoring, in clear terms, is the act of checking the behavior and outputs of a system and its components, right? So you basically want to know, how is my system behaving? What are its outputs, right? So it's all about looking out for presence or absence of patterns. Is there any anomaly in my number of requests? Is my throughput fine? Is there an anomaly in my latencies, right? It is used to report overall health of your system, in our case, microservice. So it should include your key business and system level metrics. So it should include multiple kinds of metrics, like it should basically be able to tell whether your business is running fine. As simple as how many number of bookings you are making every second, or how many number of cancellations you are having as part of your system. Or system level, like what is my CPU, what is my host level metric, like what is my file descriptors left, like how many open file descriptors are there. So, so this use was coined by Brendan Gregg. I think if you guys know, he's a performance engineer at Netflix. So he talks about utilization, saturation, and errors is something you always have to measure. And I think fairly those things are clear. Like saturation is when you actually hit saturation, whether your system is saturated. And if you have read the Google SRE book, they talk about one more term called as READ, which is you have to track response times, errors, and duration, right? Mostly like mapping the same thing, like how much time do I take to respond? What are the errors? What is the duration? So these are the key level metrics which we need to think about. If it is host and infrastructure level, you have to think about CPU, RAM, threads, file descriptors, and database connection. You need to have these metrics coming, and you need to have dashboards for it. As simple as. With respect to microservice key metrics, you need to have what is my availability of a service, what is my SLA, or in terms of, actually SLA is not the right word, SLO is the right word, whether I am meeting my SLO, which is like a service level objective, and what are the latencies, how much is the success, how much is the error percentage. So you need to have dashboards for all of this. So coming to dashboards. So dashboards actually help reflect the state and health of your system. It should capture key metrics which we just talked about, right? Both host level as well as the application level. So there are multiple kinds of metrics. You can have business metrics, as I talked about. It could have uptime metrics. It could actually tell per microservice what is my uptime, whether I'm available for 99% of the time or 1949's uptime. So we use Grafana and New Relic mostly at Gojek for all of these activities. New Relic is used for application performance monitoring. So all of the, with respect to microservice key levels, actually go into New Relic. And in Grafana, we have all the host level and infrastructure level metrics. So this is like a typical how a APM looks like, right? So this is for one of the service. Like this is, it basically tells what is the throughput, whether my AppDex is fine, is everything working fine, whether I'm replying back in a certain time interval window or not. So this is what a system level metric look like, right? Like if consider it's a Redis, right? Like how is the Redis host performing? What is the memory, CPU, and various connections with respect to that, right? So you can actually monitor those and know whether if there is any problem, you'll get to know through alerting, which we'll talk about later. So this is something which is called uptime monitoring, which is something which we built in-house through a complex data pipeline, and I think it needs to talk in itself, wherein for every microservice, right, you can actually group it per product level and have per product level uptime. Like you can basically tell that my product GoFood has an uptime and so, and within GoFood, how many services are there, what is the uptime of each individual one of them, and also what is the uptime of each API within that microservice, right? So you can actually drill down at that level and have these graphs available. So once you have dashboards, if you don't know, so basically you can't be looking at your dashboards all the time, right? You need a person for that who will continuously looking at dashboards, and if there is an anomaly, he will detect and he'll basically like send a message to everyone on Slack, right? So that wouldn't happen, right? Rather, what you need is the alerting framework, wherein if there is a problem or anomaly detected within your threshold of whatever value you set for your key metrics, you will basically alert the people who are on call. So notifying team when an anomaly in key metrics is detected is what alerting is. You basically set thresholds for all of your key metrics, and if there is a variance in any of that, you basically alert people who are on call. And the important part is alerts should always be actionable, right? So we have seen patterns wherein if alerts are non-actionable, people tend to ignore alerts in the future, right? It's a human tendency. They think that, okay, we basically took these pagers last time and they were not actionable. So let me not pick the one which is actually crucial. That could happen. Maybe actually the bookings are failing this time. So every alert should be actionable. If you have alerts which are not actionable, please, we should remove them. So it should help in alerting teams and recovering before a catastrophe, right? Sometimes after a catastrophe, right? But ideally it should be before, because so that you can recover from it. And at Gojek, it's mostly a modified version of a tick stack. I think everyone might have heard of telegraph, influx, chronograph, and capacitor. So that is what we use. So this is at a higher level how the architecture look like. You have these various hosts, which basically push metrics to a server, which is a StatsD server. These StatsD server basically push to influx, and then you have this capacitor running on top of it, like chronograph capacitors, which basically push to beacon service. So beacon service is something which you have built in-house, which basically sends your alerts to multiple channels rather than a single. So logging is the other thing. So we'll let this assimilate, right? So if you think, log events are very important, right? So if there is a fire, what would you save? If consider there is a fire in your microservice, what would you save? It is the event logs, right? Because that will tell you what happened, right? Not blockchain nor machine learning, right? True. So logging is very important. So logging helps you describe system state at any point in time. So if instrumented properly, your application should basically push those logs. It helps in debugging problems with your system. If there's any problem with respect to some API is failing because of some weird ways, you'll be able to know it because if you're logging it well. You should have structured logging so that you can actually index on those fields and then query it using something like Kibana, which we'll talk about. Log centralization, aggregation is the key, right? Just logging doesn't make sense in itself because if you can't actually visualize what is happening within my system in a centralized way, there is no point logging or making anything out of it. So Gojek has built, has spent last 6 months or so building this in-house solution called as Burrito Log. So we had a typical ELK stack initially and we were unable to scale because of the number of logs we used to produce, right? So we built something like a sharded partitioning version of ELK. So this is the architecture, how it looks like at a high level. And all the code with respect to this is open sourced at github.com/burritolog. So everything with respect to market, router, and the Fluentd plugin is open source. So at a high level, it looks like this. So router is the one which basically decides which cluster I should actually push my logs to. And it basically decides based on the configuration which comes from the market. And then you can actually have this ELK stack within each of those clusters. So it is written in such a way that tomorrow if you swap out ELK stack with something else, it will work fine. And so we talked about monitoring and logging, right? Without instrumenting the code, right? You have to instrument your code so that you can actually get all of these benefits. You can actually see these dashboards, monitoring dashboards and logging dashboards. So ability to measure various aspects of your system behavior, right? So code needs to be written to monitor specific components. I can basically tell that I can basically set a counter telling that if I have a booking completed, I can tell it, okay, let me raise a counter 1 because now 1 booking is done. Those kind of instrumentation you have to do as part of your code. It includes multiple things. It includes one is structured logging, right? On every failure scenario, basically log with certain attributes. Like it's a high cardinality data, you will basically tell whatever happened with that thing. You will have StatsD metrics with respect to what are the counters, number of bookings I am doing, number of cancellations I am having, gauges, histograms. And also I'll be having exception and error tracking. Like if there are any exceptions having with my system, how would I know it differently from just logging? So those are all the systems which are available. So you should also be able to capture application key performance. You have to integrate something which also emits these events like latencies and other aspects. So this is a simple StatsD client, right? Like we have written a small framework in which every team can use to actually just maybe increment a counter, as simple as that, with various tags and maybe a key. And we are using the standard StatsD client, which is available. So wrapping it up, insights. So basically, observability helps you provide insights into service health and behavior. It will provide insights into your service performance. It will help you debug in production, right? Which is extremely important. If my bookings are failing or if my cancellation has increased, right? What should I do? Why is it happening? If you're able to find it, you need those metrics available somewhere. So it will help bring visibility into your microservice system. And basically knowing when things go wrong is something which is extremely important. And it will help you with stability. So the last one we'll talk about is the documentation part. And this is something which is very dear and near to me because I am a proponent of documenting more than writing code, because you have to document more, because all the things you are doing is for other people to consume. If tomorrow new people join in team, you need a very good documentation for them to onboard. Or even if someone changes teams, you need a doc for your microservice. So for a microservice, if it's an API microservice, you have something called as API docs. So these basically represent the API contracts of your service, which you want to always hold true when some other people are integrating with you. So it will basically include all those contracts like request, response, bodies. So it should provide enough information for integrating with your API. Like as a third-party person, if I look at your API docs, I should be very clear on what are the contract you are expecting out of me. It shouldn't be bad. So we are using Swagger for specifying the API docs for all of these microservices. So it looks something like this, right? Like if you have a microservice, you can actually go there and check what are the headers, what is the body, what is the contract, how can I actually integrate with it? As simple as that. And this becomes extremely important when you actually want other people to integrate with your microservice. Okay, so how many of us have heard of ADRs? I think this is a new term, like architectural decision records. I think it's a new term for the same old thing which we do anyways, right? So it's a document to capture important architectural decisions and design, right? So your architecture actually goes through a varied phases of evolution. And you need to know when a certain decision is made, why it was made, what was the set of constraints in which it was made. So those need to be clearly documented. Because if tomorrow someone wants to know how did the design evolve to the place what it is currently, what were the steps which went through, what were the constraints which people had. So it should be versioned, like you should have various versions for your architectural decisions. Oh my gosh. So okay. It should capture context and assumptions because that will help you more than actually just writing down the design of whatever you're trying to build. You should be telling what was the assumptions with which I designed my current system. That becomes extremely important. Helps in understanding why some key architecture decisions were made, right? It will bring in empathy of people who are actually seeing your design maybe 1 year down the line. They shouldn't just come and say, oh my God, your design is shit because it doesn't scale. It should basically provide you information on what are the assumptions or constraints you had when you designed them and how it should evolve in the future. It will also help alignment across different teams, right? Since microservices is all about knowing, right, through an interface that, okay, this piece of domain is being done by this service. If you clearly define what are my boundaries, right, you will be able to have alignment across multiple teams. And a typical decision record would look something like this. You will have a status, right, whether it's accepted or it's still in review process. You will have a context on what is the context, what is the background on which I am basing my current design. It will have a decision on what is the decision I took for actually solving this problem, right? It will include your detailed architecture diagrams. It might include sequence diagrams for showing what is the flow. And then consequence, right? If I am doing this design, how does it affect other teams? So if you document this clearly, it will be extremely helpful tool. And I think other people will actually thank you later. I think this is something which has worked out very well at Gojek at least, because we are making sure that any service or any design decision you take should be documented. You shouldn't be just going out. It should be documented, reviewed, and then it should actually be implemented. So the next thing is runbook, the last part. So runbooks are basically, it will help on-call developer to have step-by-step instruction to find, resolve, and mitigate the root cause and alert. Like we talked about alerts, right? Like consider latencies have increased for your microservice, and it basically sends a pager to your on-call person. Now, if your on-call person doesn't know what are the step-by-step things I need to do to actually fix this problem, right? There is no need of an on-call person, right? You should know. You should know what are the things the person needs to do. If you document that clearly, then the we call it as mean time to recovery, right? I think the MTTR can actually be improved, right? Because now you are, everyone within the team will be on the same thing. I have to do these 10 things to actually check what is happening with my system. And if I find anything there, I should maybe do something about it. So it should clearly document that. I'll show you an sample one, a very, so it should basically have different like host level and infrastructure alerts. Like if there is a problem with respect to open file descriptors, what are the set of runbook I should follow? Versus if there is a problem within my microservices, right? What are the runbook I should follow? There are different set of runbooks you actually get. So these are on-call runbooks. It will help you in the reliability of your service and also help you recover quickly from failures. And it will help you in preventing catastrophe, right? Because now you actually be acting on what has happened with the system. So a sample runbook, this is very trivial, but consider we have a booking history service, right? And it has gone down, right? Like it's like users are unable to see any booking history. So but as simple as this, right? Check the process status for the service, right? You will have a dashboard for the process status. If it is up, if it is not up, okay, check the throughput. Like if that doesn't give you significant thing, check the throughput. Whether any throughput on this, whether there is any request coming to this. If it is not, then maybe process has died. If you have checked the process status, just go and restart, right? As simple as that. But the runbooks could be as complex as you want, but it should be something which should be actionable. If I do it, it should be able to fix the problem. So closing comments on documentation, it will help you bring clarity in thought for yourself, because now you are basically writing it down, and as we all know that if you write something down, you will crystallize your thoughts. That is extremely important. So helps in incident response during outages, right? It will help you recover faster. It will help you in alignment across multiple teams, because they are now know what is the clear domain which this team is working on. It will help you with catastrophe preparedness, stability, and reliability. So the other checklists include security, right? Like authentication, authorization, canarying, like how you should make sure that every change, every feature you go into production should be canaried, and you should have proper monitoring dashboards to make sure that you actually roll it out to 100% people. How you should have a stable CI/CD pipeline, right? You should have something which properly packages, properly builds, and properly deploys. It shouldn't be something which just breaks, right? You should have a stable deployment process there. You should have dependency checks. You should basically make sure that the dependencies which I'm using, right, are all in well good condition, or they still hold the contract as we talked about. And also this is going without saying, right? You should have HA on all of your storage layer at least, so that like if you should be fault tolerant. So wrapping up, so we talked about all of these aspects. So the key takeaways being at Gojek, we follow a concept of having code health metrics. Like every team or every microservice have this code health metrics which tells test coverage, which tells what is the quality of the code. You should basically be able to rate a code base, telling that it's an A or a B. That will help you know how is my code evolving in the microservice. You should basically go with observability-driven development, which means that you should instrument your code as much as possible, right? So that you can actually get to know when something has broken in production. And test pyramid is something we have to follow. Document everything. I think this is something which I have learned the hard way. If you don't document something, it will be very bad for you yourself, because you won't be knowing what I did a day back, right? As simple as that. If you document it, it will crystallize your thoughts. And you have to think of failures at your integration points, because complex microservice architecture will fail, some service will go down, some host, like some Postgres will go down. You have to be prepared against them. So in conclusion, with respect to production readiness checklist, the thing was we want to standardize quality. We want to make sure that microservice held a particular quality before it actually hits our production and our users use it. Because we don't want our users to use sub or subpar quality products, right? It should be something which should be available for them always. And availability is the goal. At the end of the day, we want to be available for serving our customers 100% of the time. But 100% is something which is not ideal, but that is something you can actually aim at. What next? So with respect to production readiness checklist, you could, if you think, most of these items can be automated, right? You can actually tell that, okay, have a bunch of these services, modules running in themselves, and have APIs exposed to actually find some kind of score out of all of these items. So we were planning of something like a production readiness score, right? Like every microservice which is currently in production or which is about to go will have a score, and if it meets that score, like consider out of 10, it meets 7 and above, then only it can go above, right? Otherwise, no. You have to make sure that you do some of these aspects compulsorily. For that, you have to define what are the must-have and what are the should-have, right? So that is something which is defined clearly. So assigning every microservice a readiness score and help teams improve quality of microservices which are currently in production and also the microservices which we'll be putting in production later. And the other thing which we have learned is you have to always measure the impact and improve. Like check that we have rolled it out, to measure the impact. If there are any problems, improve. And repeat, rinse and repeat. So these are some of the references. So the idea for this talk also came from this book called as Production Ready Microservices. How many of us have read this book called as Production Ready Microservices by Susan Fowler? She was a SRE at Uber. So this is a book which I would highly recommend reading because most of the ideas were from this book and basically directly mapping into Gojek context, as simple as that. And of course, Google SRE book and some of these other things. So that's what I wanted to say with respect to how we build production ready microservices at Go. Thanks for listening. I think it went on. So if there are any questions, I can quickly take some if we have time. So are we good on time? Should I be taking all of them or only some of them? Like, touch. It depends on the time because I don't know how much time do we have.
So we have about 5 minutes to answer the question.
So we'll start with the first one. Do you have first line support who try and use runbook to solve problems before call dev team? Okay. Do you have first line support who try use runbook? So the support is basically done by, we have an SRE team internally. So basically SRE team sets these runbooks for host level because they'll be managing the host level metrics criteria. But if it is something which is like a microservice level, it will be the teams who will be defining it because they have context on the domain. And if you want support writing any of this, I think the SRE team would be helping you do that. I think if that answers the question, like whoever asked it. If it is no, just say no, I'll just go ahead. So can you share some points? What is the current uptime of Gojek system? That is something I can't share because, so we haven't actually like put that number out, but I think if we put it out, it will be on our blog. So I can't share that currently. How long it would take a change to go throughout all items in your production checklist to get deployed on production, assuming there is no issue along the way? I think currently it's a day or two because it's not an automated process. Like people basically have to go through these checklist items to find out whether they have done this, done this, done this. Sometimes what happens is that based on the checklist, it actually happens like within a day. You can just consider that. But once it is automated, I think it should be much quicker. Okay, so contract testing with gRPC. What has been your experience, especially at Gojek? So on Gojek. Hello. Yeah. So contract testing with gRPC is something we haven't tried out. So most of the contract testing which we have are for RESTful APIs, which are over JSON, right? So we have our whole payment division which uses gRPC, but we haven't tested contract testing for that. Advice, Go Meta linter is slow, this one much faster, but still slow, okay. Question, do you reject deploy if linter is not passed? Yes. So we reject the deploys, so nothing goes to production if the linters don't pass. And of course, you have to pragmatically think, right? Like, do I need all linters to run? You basically skip certain linters, you basically define your own language of what kind of quality you want within your organization and apply only those linters, right? So that is what we do. Like you pragmatically decide, you just don't go blindly and tell that I want it to run all the linters. Okay. So there are two ways. You can have a pre-push hook too. We do it for certain services, but we also have a code quality step in the CI/CD pipeline where you can't actually do a build publish if this don't run. So are there any questions in the audience? So we are done with the online one.
Okay. Does each microservices have its own SLO?
Yes. So basically SLOs are service level objectives, and there are service level indicators. So service level indicators are something like your latencies are service level indicators. Your objectives would be that 99% of the time my latencies would be less than 10 milliseconds. So that is my service level objective. So you define service level objectives, and SLAs are much more contractual level. Like what if I break this? Like consider I am using third party service, and if they break their SLO, telling that okay they want to be up 99% of the time but they are not, then I can actually have some way of negotiation telling that I want my money back, or like give me this concession or whatever, right? That is in your agreement which you form with the third party service. So that is an SLA, which is like an agreement which you form.
How do you define SLO?
So SLO gets defined on multiple ways, right? One thing is you define on by running the load testing, as we saw, like okay, I have this service or whatever, and I want to handle this much traffic, right? What is the current status of its SLO? Like consider, see, we want to be up 4 nines all the time. At least at Gojek, we always want to have 4 nines uptime. Consider, right? So, and with respect to responses, like the latencies, we want always to be in sub-milliseconds, but that's not possible because you are now have dependencies, right? So it's a thumb rule telling that, okay, if your latencies are like within 10 milliseconds, for example, for like main critical flows, you are good. Because that is the experience, it depends, it drives through experience, right? Like consider if I am making a booking and the price estimation takes a lot of time, for example, that's a bad experience for me. So it like fairly, like it mostly drives through the UX. Like, okay, if it is fine for the user, if it looks fine on the user side, then I think on that aspect, most of the microservices should have less than 10 millisecond latencies. 99% of the time.
Thank you.
Any more questions? Cool. So if you guys have any other questions, I'll be available. You can just talk with me on how we build microservices and all those aspects. Thank you guys. Thanks for listening.